Yeah, radicals. So cool. Much wow. And you're probably thinking to yourself, what the heck is a radical? I don't recall any radicals. Does anyone want to guess on what a radical is? I mean, I think all math is pretty radical, but something that's rad. I love that. Okay, someone thinks it's a ratio of sorts. I like that. A nonconformist number. Ooh, undoing an exponent. It does have something to do with exponents. That's great. So if you were here last time, we talked about exponents. Okay? And these are following off of those. And honestly, I've done videos about things that were radicals before. It's with square roots and stuff. Got no roots from, yes, we're going to be talking a lot about square roots today. My video is mirrored, so like I can't always react well on. Anyways, that's why I was like, it's over here. No, it's over here. Yes, it has to do with square roots. It has to do with exponents. It's basically square roots. But then square roots isn't where it ends, right? There's more than just square roots. Kind of like how there's not just squares, right? We don't just have x squared, right? We've got a bunch of things. We've got like x to the third. We can have x to like the 27th. We can have x to whatever freaking number we want, right? Whatever feels good in our hearts. 367. I don't know. It could be any number, right? We don't just have x squared. And similarly, we don't just have square roots, right? We don't just have this. There are many other types. There are many other numbers that can be involved, okay? So let's talk about it. But first, let's break down what is a square root. What are we doing when we do a square root? Because I think we get lost on that. We're going to be talking about a bunch of rules today with this. But first we need to understand what is that basic part of this. What are we just doing? Okay? So, here we go. So first we're going to just start with breaking down what is a square root. Okay? What is a square root? Now, to kind of break down what a square root is, it's honestly the opposite of squaring something. In math, we talk a lot about opposites, right? If I have adding, the opposite of adding is subtracting. If I have multiplying, the opposite of multiplying is dividing. We have ways to do things, and we have ways to undo things. It keeps that nice balance. That's what radicals are to squares. Okay? That's what it is. It's that opposite. It's that nice balance. All right? So if I have a square root, words are hard. If I have a square, if I'm squaring something, all right, let's look at what I'm really doing there. And right now, you're just kind of holding my hand and trusting me as I talk you through this, okay? We're just holding my hand and trusting me as we talk through this. Yeah, honey's just let the mods do their things, and I get personal enjoyment out of it because you're still gonna soak up some math, okay? So, anyone who wants to be here, I'm glad the trolls can get a little bit of math too, okay? Have fun with that. But just stay focused on this. Don't give them fuel. Don't feed them. Just enjoy this and stay focused. All right, so what we're doing right now is I'm just going to talk through some stuff. You are going to hold my hands and you are just going to trust me on where we're going, okay? You're not going to panic. You are just going to trust that I'm taking you somewhere and explaining something, okay? Great. All right, so if I have an x squared, I have something squared. Let's use the example of 3 squared. What that is really saying, if I were to draw a picture, right? It's saying that 3 times 3, which I can express in a picture as 3, right? If I have 3 by 3, right? This is another way. These are all ways to write that 3 squared. And we get that 3 times 3 is 9. If I were to count up all these squares right, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Bam! It's all the same. So where does this bring our square roots? Right? Where does this bring our square roots? Our square roots come in by saying it's the opposite. It's the undoing of it. So if I were to say the square root of 9, what I'm really saying there is what number would make the square? What side lengths would there be to the square? That's why we call it a square root, is because I'm asking what side lengths would make a square that holds 9. That's why we call it that. I think that's kind of cool. That's what a square root is doing. It's undoing that for us. So the square root of 9 is 3. My side lengths need to be 3 to get a square with 9 in it. Nice. So every time I'm seeing something like this, it's undoing this. It's just undoing this. I think that's really neat. I hope you think that's neat too. And remember, I've seen some people that are like, my brain hurts. That's okay. That's actually a good thing. I'm really proud of you that your brain hurts. You want to know why I'm really proud of you that your brain hurts? I'm really proud of you because it's like if you went to the gym, right? If you went to the gym and you're like, oh no, I must not be good at lifting weights because my muscles hurt now. Well, your muscles hurt because you worked them out properly, right? That means that your muscles are going to get stronger. Your brain physically hurts when you are pushing it because it is literally making connections. Your brain is growing, right? Your brain is full of all these little synapses that are growing and myelinating, and they're basically getting stronger, right? You are getting stronger. Your brain is getting stronger. So every time your brain hurts when you're learning something new, I'm so proud of you. Yes, it should. That's great. That's perfect. Okay? You're doing great. And even if you don't get this the first time or the second time or the third time or the fourth or the fifth or the 10th, that's okay too. Because we all learn at our own pace. We all do. And we all have our own things. I personally have a learning disorder. That doesn't mean I can't learn the things, but it means that sometimes it's harder for me, and that's okay. I'll learn it at my own pace. Things, but it means that sometimes it's harder for me, and that's okay. I'll learn it at my own pace. And you will too. Just don't give up on yourself, okay? Good. All right, now that we've had that wonderful pep talk, I hope it was wonderful. Let's keep going. We're going to extend the square root, right? Because I told you before that it's not just this. It's not just that this is like the opposite of this. Because I've got things like x to the third, or x to the fourth, or x to the fifth, right? So there's more than just this. Because we have to be able to undo all of those. We have to be able to undo all of those. Okay? So we're going to take it to what those look like. We're going to start talking about their opposites. Let me get my eraser. Where's my eraser? Where is my husband? Oh, here he is. That joke will never get old for me. I hope you all know that. Yeah. All right. I'm trying to think of how I want to phrase this next part, okay? Oh, getting close to the screen there. Yeah, my eraser. Isn't that delightful? I love him. All right, so let me think on how I want to phrase this next part. Give me a second. I need to get my story straight. Let's put it this way. We're going to talk about things we do and how we undo, okay? So I'm just going to write do and undo. There we're kind of talking about their opposites, okay? Does that feel okay? You get what I'm saying there? The thing we do and then how we undo that thing. You're right, I need to be straight, but I'm not. But anyways. All right, cool. We'll start there. All right, so I think this lesson might be multi-parts. We'll find out. If I have x squared, and we've been talking about this one, right? If I have x squared, the way I undo x squared is I can do this guy, right? A square root is kind of like the opposite. But there's another way to write this guy. And I'm going to show you that, okay? There's another way to write it, and this kind of opens up how we write all the rest of them. Here's how we can write this guy. Okay? Let me just double check so I know I'm writing it correctly, because sometimes I get a little turned around. Oh, no, got it. There's actually two ways I can write this. I can write it this way. I can also write it this way with the little 2 up here. Okay, the little 2 up here. But there's also a secret third way I can write it, which is that way. X to the 1/2. I'm just going to give you guys a moment to write that down, and we'll talk about it, okay? Because everything else is going to stem off of that concept. Oh, this is the best math class. Yay. Little happy dance. I'll give you guys a moment to write this down if you want to, because everything else is going to stem off of this. All we're saying right now, why the half? That's a great question. That's a beautiful question. So all we're saying right now is that this is x squared. The opposite of that is the square root. And one other way to write the square root is with the little 2 up here, because that 2 up here is saying we're undoing this 2, okay? It's saying we're undoing this 2. Our default is this. This is kind of our default guy. We do this the most, so we said, let's get lazy and not write the 2. That's literally it. It's literally we don't write the 2 because it's the most common one. But it's not incorrect to write the 2. It's just mathematicians being lazy. Thank you for the gift. Another way to write it is this 1/2. And someone said, why the 1/2? You know what? I'm going to mathematically prove it to you. And then we're going to erase it, okay? Because that's such a good question. And I can show you. If you think back to a couple times ago, we talked about some properties with multiplying exponents, right? So if I have, my goal here is for this to be undone by this, right? So if I have 2, and then I multiply that by x to the 1/2, right? That ends up being 2 times 1 is 2 over 2. So that ends up being x to the 1. I ended up undoing it. Just like how if I took the square root of x squared, that would just leave me with x. This is why we can write it this way. Another way to remember why I can write it that way is that there can be a secret 1 here. We don't always write that 1 because, anything to the power of 1 is just itself. So it's not really necessary to write it, but that secret 1 is always there. So that's where those numbers end up coming from, is the x to the power of 1, 2 in the side. That's going to be important for later. That's going to be important for later. Yeah, I'm out of school too. But we're still doing it. I love that. And I love that you're here. All right. I'll give you a moment to get this down, and then we're going to continue this kind of chart to start to see a pattern and guess a pattern, okay? Because math is all about those pattern recognitions, okay? Thank you for the gift, honey. Thank you. And I'm glad that some of you find this very helpful. That makes my heart very happy. Oh, I do put these lessons up on YouTube. You can find these on my YouTube channel, and you can find my YouTube channel in my link tree. Right now we're working on building out a resource. So this is actually building on other lessons for Algebra 1. All right. I'm going to erase this now. Please help me out, Azawa. And we're going to continue this pattern to start to see the pattern in what's happening here. Boop. Okay, so let's say now, this is algebra. This is an Algebra 1 course. We're working through an Algebra 1 course. And after we work through an Algebra 1 course, we'll move on to other courses, okay? So let's say I had x to the power of 3. It's going to be very similar. Okay? Yeah, it's going to be 1/3. Yes! Yes! Nice job. Nice pattern recognition. One way of writing it would be x with a 3 outside, and we can write the little 1 here if we want, or we don't have to because x to the power of 1 is 1. Or we can write it as x to the 1/3. Both are the same thing. He's watching and he's a math teacher. Hi from one math teacher to another then. Yep, so if we were to undo it, we'd get that x to the power of 3 over 3, right? If we did x third times x to the 1/3, we'd get that, so they'd cancel each other out. That's why this guy cancels this guy out. This is how we undo this. That's its opposite. Yep, something to the power of 1 is not 1. Something to the power of 1 is just itself. Kind of like how, it's kind of the same thing as like when we do like 2 times 1 is 2. 2 to the power of 1 is also 2. All right, so it would not be to the power of 3 over 1? That's a good question. It's not going to be that because we wouldn't write it like this, right? We wouldn't need this radical. Like bringing it back to this guy. This guy's kind of closer to division than anything else, right? If we said x to the power of 3 over 1, that'd be x to the power of 3, which is what we have over here. Oh, you may have been saying, can we write this guy like this? And yes, we can write that guy like that. We don't need to, but we could. All right, moving on. If I have x to the power of 4, that's like too big of a 4. Oh my gosh. What do we think that guy's going to be? What's x to the power of 4 going to end up looking like? Take a moment and guess in your head. If you want to say it on the chat, you can. I know it could be kind of hard to write these out. But it's always good to make a guess in your brain. Awesome, 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 my dears. Oh, thanks for the panda. Oh, you guys are all so freaking smart and beautiful. Are we kind of seeing the pattern? Nice. Nice. So yeah, one way to write it with the radical, we call these guys our radicals. These are isn't it radical? Is we can have the 4 up here and an x and a little 1. We don't need the 1, but we can have it. And that's the same as x to the power of 1/4. Nice. Oh, I'm sorry you didn't get notified that I'm live. I don't think we have time to go back and prove it again, but I will be posting this on my YouTube, so you can go back and watch this as many times as possible, okay? All right, so honestly, if we kept this going, right? To the 1/2, 3, 1/3, 4, 1/4. They're undoing each other, right? And this is how we can write them out with a radical. So honestly, if I had x to anything, let's say x to the power of y, it would just end up being, oh, that's, come on, Thistle, get it together. There we go. X to the power of 1 over y. It would just follow that pattern. Nice. All right, we're going to take this a step up in just a moment. I'll give you guys a chance to write this down if you need to. And then we'll take this a step up. I think radicals is going to take 2 days. That's okay. That's okay. We'll just kind of learn the basic rules of what a radical is today. And then next time, we are going to be going in and playing around with these guys, doing some fun stuff with them. Okay? What I mean by doing and undoing, it probably wasn't the best way of saying it, but it was a way of saying it, is I can, if I do x squared, I can undo that with a square root. I can undo x to the third by taking the radical to the power of 3, right? I can undo each of these. Kind of like how if I multiply something, I can undo it with division. If I add something, I can undo it with subtraction. Just those opposites. All right, so let's take this up a notch, okay? I hope you got this down. Again, if you're coming in late, if you missed any part of this, if you need to see it again, That's okay. I'll be posting these up on my YouTube channel, okay? All right, so you guys noticed how I had like the 1 up there, right? There was that 1 and it ended up being like 1/2. I can write that one again. And if you want to find my YouTube channel, it's in my link in my bio, okay? Or if you just look up Thistle Witch on YouTube, you should be able to find it. I'm the crazy Mike cosplayer teaching you math. You know, it's that one. All right, so like if I have that, if I have this guy, right? I can write that as x over 1/2. No, I want to flip that around. Sorry. I want to flip that around. Let's do it this way. If I have x to the power of 1/2, I can write that like this. Right? I can write it like that. So now what? Oh, thanks for the gifts, my love. If I had x to the power of 2/3, oh snap, can I write that as a radical? Can that be radicalized? Yes, it can. Yes, it can. Yeah. Let's radicalize it, shall we? And I want you to, in your brain, take a guess at what you think that's going to look like radicalized. Take a guess. Thank you for the little dinosaur. Because when you take a guess in your brain, even if you're wrong, your brain's going to remember the answer that much better if you make a guess. So always make a guess. Oh, I'm seeing some beautiful things. Yes, yes, yes. All right. So another way of writing this guy, this boy. I'm going to put my X there. My 2, right? We're just following the follow the blueprint up here. Oh, I erased it. That's not my job. The 2's going to go here, right? Like the 1 went here. And the 3 is going to go on the outside. The denominator goes on the outside. The numerator goes on the inside. This is just another way of writing it. Why the heck is this useful? Why the heck is this useful? Hopefully we'll get to it today. If we don't, we'll get to it next time. But it's all about learning how to write these in different ways can help you manipulate stuff so that you can play around with your numbers and figure out cool stuff with them. Because I like to think of math a lot of the times as a puzzle. It's a brain teaser, right? And you gotta play around with it and get messy and try it in different forms sometimes to see if you can make any sense of it. It's a big old puzzle. Think of it as like a code you're trying to crack. So sometimes you gotta be able to manipulate it. Have fun with your math. Play around with it, okay? Yay. All right, so let's try some others. I'm going to give you some, and I want you to try and write them as a radical. We'll do. Take a moment, my dears, and make these radical. That's a 7. You can't see that very well. There you go. Hopefully that's better. Oh, thanks for the donut. Take a moment, make these radical. Meows. Yeah, good luck studying for your GED. I believe in you. You can do this. Water. The scenario where you would need this outside of school? Science. If you want to do anything with science, this is going to be very important. This could also be important. Some of these, the smaller ones, are important in construction as well. So good question. These honestly are just basic building tools that get applied in different ways. So without a doubt, science. So if you're doing anything with physics, these are going to be important. Anything with complex building is going to be really important. Another fun application is if you have children and they have to take this and you need to help them. That's a lame one, but it's true. Thank you for the gifts, honey. But yeah, no, honestly, it's very applicable in science. You can't get away from it in there. If you're doing anything with building, anything with physics at all, you're gonna need it. You're gonna need it in any science field. And honestly, I like to think about math as I'd rather have it and not need it than need it and not have it. Mathematics is going to open a lot of doors for you. No one, when you apply for jobs or they look at your transcripts, no one is ever going to look at you and go, oh gosh, we can't do anything with you. You took too much math, right? Sometimes math is even just used by companies and by different occupations to prove that you can learn a complex thing, right? So sometimes it gets used as this weird gatekeeper, and I don't like that, but it's also an honest answer. I don't like that answer. I don't like that it gets used that way, but it's an honest answer. Cool. All right, let's see what these look like. Also, honestly, it's just a fun brain teaser too. I think these are fun. When you're not being pressured and graded on them, they're kind of a fun brain teaser to manipulate and play with, and hopefully we'll get to some of that today, where I can show you what I mean. And when we get to that point, I don't want anyone to like panic on that, like they didn't get it the first time, because when I say play around with, I honestly mean play around with. I honestly mean try it out, see what happens. Go back, fix it, right? Go back, try something else. Math is just playing, and honestly, mathematicians get stuff wrong all the time, and they have to go back and check and play around with it and all that good stuff. All right. Take your math less seriously. If you get anything from me, it's take your math less seriously and have a little bit of fun with it, okay? All right, so this guy, I can write him. If I'm going to make him radical, we're giving him a radical makeover. All right, X goes in the center. Cool, that's my base. All right, the 5 sticks with my X. The numerator sticks with it. The denominator goes over here. Bam! Let's make this guy radical. We're giving these fraction exponents a radical makeover. Gotta get ready for the club. Gotta redraw it. All right, the 9 goes in here. 21 goes on the outside. Yay, you got it right. I'm proud of you. The puns are atrocious. I love it. Yay! All right, then we've got this guy. The numerator, the 4 goes in here. The denominator goes on the outside. Woo! We did it! Thank you for the gift, hon. We did it. We did it. Nice. And yeah, someone's pointing out that you can reduce some of these, and you can. Let's get to that. Give people a moment to write this down if they need to. And then we'll try doing... We'll try something. I'll show you something. I'll show you a thing. Okay? We're actually, yeah, no, I know what we'll talk about next. There's a lot to talk about with these, sorry. Thanks for the gifts. Okay. Where's my eraser? There he is. Burp, burp, burp. He's a very good eraser. He's very good at his job. Look at that. That's clean. That's nice. That's nice. All right. All right, we're gonna make some other things look pretty radical, okay? Well, he's a pro. Thank you, Crow, for that joke. That was delightful. He is a pro. And he's definitely my hero. All right. So we're going to radicalize some other things. Make them super radical. All right, let's do this. Let's say I've got a whole string of things like this. Let's say I have 5 x to the 3 y to the 7th, all to the 1/2. Don't panic. I've just added more. It's all going to be okay. Yeah, this gets used in chemistry sometimes. So that's a fair assumption to be like, is this chemistry? I have cosplayed at school before. Don't panic. It's okay. Remember, complex math is just simple math stacked upon each other, wearing a trench coat, trying to get into an R-rated movie. It's not as bad as it looks. It's not as bad as it looks. It's just we've added them together. No, it's we only panic at the disco. That's okay. It's okay not to be good at this. That's why you learn about it, right? I always love when people walk into my math classroom and they're like, I'm not good at math. And I'm like, yeah, that's why you're taking a math class. And they look at me like I'm crazy for a moment. And I'm like, well, why would you take a class if you already knew how to do the thing? Why would you take a class on that? You take classes on things you need to learn. You take classes on things you need to learn. It looks hard. It's not that bad. All right, so let's talk about it. Let's talk about it. And you know what? To talk about this, I'm just going to straight up break this down for you. Because it's not that bad. Let me prove to you that this is not that bad. We're going to break this up into pieces. What if I said 5 to the 1/2? What if I said x to the 3rd? The 1/2. What if I said y to the 7th? And the 1/2. If I radicalize each of these, what are they going to be? 5 to the 1/2. That boy is just going to be the square root of 5, little 2. Right? So if I do this guy, I'm going to do 3 times this 1, right? Because both of these are going to be connected to this, right? Because when I did my radical, x to the 3rd, and then we'd have that little 1 in there too. 3 times 1 is just 3. Yeah, right? It's not that bad. Once you can break it up into bite-sized pieces, it's okay. The problem we often run into with math is that we try and like take it in all at once and then we choke and die. That was a graphic metaphor. But if we break it up into little bite-sized pieces, it's okay. It's okay. So similarly, if I have this y to the 7th and then this 1/2 out here, and again, we're just applying rules that we applied before. I can even break this down a step further, right? Because we did this rule last time. We talked about exponent rules last time. This y to the 7th with this outside is really, we multiply the insides, right? So I do 7 times the 1, gets 7 over 2. And that we know how to write as this. So now I can just throw those guys all together to get my answer. Yay, we love math, yay. I can just now put these guys all together to get my answer. And they can all, they're all friends. Look how close they are. They can all go under the same radical. The 2 goes out here, okay? And then I have the 5, the x to the 3, and the 7. Nice. That wasn't so bad. We cut it up into pieces, and it got better. So remember, when you're struggling at math, when you're getting overwhelmed, see if you can cut it up. See if you can slice it up into smaller pieces. You probably can, and that makes your life a lot easier. Yay, we're kind of getting it. That's awesome, because kind of getting it is the first step to really getting it. I'll give you guys a moment if you need to write this down, and then we'll talk about another one, okay? Perform fruit ninja on radicals. Heck yeah. Ugh. Can you be my teacher forever? You guys are sweet. This one actually can't be reduced. We'll talk about that, but this can't be reduced. That's our next step. I'm trying not to make that situation right now. Someone brought up reducing, and reducing is important. This one, we can't do that. This is the simplest way to write it. We will get to that. We will. I like the be gay, do math. I really do. And, like, I don't like when there's, like, that stereotype of, like, gay people can't do math. Because it's like, what do you think Isaac Newton was? What do you think the father of calculus was? That man was. Okay? We don't talk about it. We don't talk about how much women and people of color and LGBT people have contributed to mathematics, but honestly, it's a lot. It's way more than white men ever have. Okay? Yeah. Math is super, super diverse. All right. Let's do another one. Let's do another one. Another one. Okay. Math is nonlinear, so it's not straight. Obviously, that's a great joke. I loved that. Okay, so let's do this. Let me think of another one. I hope you all know that this entire thing is just me pulling it out of thin air. I hope you understand that. So I was like, I got the basics. We're good. I got it. That was a weird 7. We're going to try this. We're going to give this a try. If you want to try it and work ahead, go for it. Otherwise, we are going to break it down together, okay? If you want to try and write it radical. Yeah, it's a y to the 9th. Sorry, my handwriting is not the best. See what my students have to put up with all the time? Eesh. Luckily, they get a break from me now. Line graphs, nice. Yay! Excited about math. If I can change one person's mind and heart about what math can be, I've done my job here. How am I doing this in my head? Lots of practice, years of practice, years and years and years and years and years and years and years of practice. When I was in high school, I was like, math teachers are crazy. How can they just do this? It's all I do. It's all I do. And when I went to college, I straight up first got my BA in mathematics, just a straight up degree in mathematics. All I did was mathematics, just math, math, math. So that's all I really needed to worry about. And then I got my master's degree in math education. So lots, like anything, like absolutely anything, it's practice. Lots of it. Difficult. Sorry, someone was like, what's math college like? Difficult. Hard. There's a reason I say crying under the table is an intricate part of the mathematical process. It was hard. But it was worth it. It was worth it. I really enjoyed a lot of it. I learned a lot of really cool things. I had my brain broken wide open on what math could be, which was really fun. And it turned me into a crazy person for a little bit. I mean, I still am. Like, has anyone ever seen, sorry, aside, and then I'll finish this problem. Has anyone ever seen, like, the Big Bang Theory episode where, like, Sheldon's been up all night and he's working on this, like, equation and stuff, and he's writing on his whiteboard, and then his roommate gets up and he's like, maybe you just need a fresh look at it. And he's like, that's a good idea. So he takes the whiteboard and he throws it out his window. I saw that when I was getting my BA in mathematics, and I related to nothing more heavily than that. It was like, there were times where I was like so sleep deprived and everything. I'm like, I'm just going to throw it out the window. I just need to start fresh. Throws it out and he's like, thank you. That was a great idea. Pulls out a new whiteboard. And I'm like, that is where my brain's been at. So like anything that's worth doing hard, but you know. All right, let's do this. So I've already seen some guesses. I'm not going to write this out quite the same way as I did the last one, but we will work through it piece by piece, okay? I know I want it to look all radical at the end, so let me put that guy in. And let's start with the 7, okay? We're going to have that 7, and the 7 to the power of 2/3. I'm just ignoring the rest right now. 7 to the power of 2/3. That's just going to be that, 7 to the power of 2/3. So the 2 goes here. The 3 goes here. All right. Now we're going to move to the x squared. Nothing but that x squared, okay? That's all I'm worrying about. Now I have this 2 times 2, right? What's 2 times 2? 2 times 2 is going to give me 4. So it's going to be 4 over the power of 3. So I can write that as x to the 4th with the 3 out there. See what we did there? We're taking it piece by piece. Numerator times numerator got me that 4. 3 goes outside. Hopefully soon. I know I haven't uploaded the last one to YouTube yet. The end of the school year has been crazy. I am an actual teacher, so hopefully soon. I'm really sorry for the delay on those. All right, now let's focus on just this y to the 9th, right? 9 times 2. 9 times 2 is 18. So I'm going to get y to the power of 18 over 3. Cool. Real question, can I divide 18 by 3? Yeah, I can, can't I? That's 6, right? Or am I tripping? Yes, I can. Cool. Dang it, I didn't want to make it able to reduce. I want you guys to just focus on this for a hot moment. Sorry, I'm frustrated with myself. Oops, right? That's what happens when you make them up on the spot. All right. Do you guys want me to reduce this one, or do we just want to focus on this process first? You can change the number. We saw nothing. How about let's do... The reason I did 2 times 9 is because 9's in the numerator here. So 9 times 2, because that's a property of exponents. We covered that one last time, so I'm not going to stick too hard on that one. You guys want me to reduce it? Focus on the process? Let's just focus on the process for now. I think some people are ready for reducing, but I think some people might need to see the process one more time. We got a little bit of time. Let's do the process one more time, and then we'll reduce, okay? We will get to reducing, don't worry. Let's do the process one more time, and we'll make that one reducible, so then we'll go into reducing, okay? But let's focus on just the process one more time, and then we'll reduce. Just know this can be reduced. This isn't how I'd leave it. I just don't want us to get stuck, right? I want us to pick up one piece at a time, because like I said, if we try and swallow the whole thing, we'll choke and die. Pieces are good. Pieces are good. We put the whole thing together at the end, right? Sorry about that. I was trying really hard, and then when I saw that 9 and the 3, I was like, maybe I did something there, and I did. It's still technically correct, you're right. It's just not in its simplest form. It's radical, it's just not ready to go out on the town, right? Because we always want to reduce things when it's our final answer. Because, again, we'd use this in science, and it makes way more sense to my brain if I'm reading like the results of a test really fast. It makes way more sense to my brain to see it as simple as possible and not in huge complex numbers, so that I can make more sense of it more easily. If that helps. That's why we always reduce. That's why it's a good practice, because a lot of math gets used in science, and in science you want to make sure you reduce so that you can read things really, real quick. You heart my necklace? Thanks, it has my husband. So pretty. Yeah. All right, let's do another one. 5s are good. I can't remember what numbers I just used. I'm not going to lie to you. Actually, I don't know if this one can be reduced, but let's try this one. Let's try this one. Give this one the old try, and then we'll talk about it, okay? I'm sitting on the ground. Oh, it was actually made for me by someone. The necklace was made for me. My forehead's a little shiny. Give you guys a moment. And then we'll try this. I'm glad my videos can make your day. Ooh, I love that we got them guesses coming in. Yeah. I just drew on my forehead. I did. Awesome. Doesn't help that this is mirrored. We'll deal with that later. I can't. There's some above the eyebrow. Oh my gosh. I'm a mess. All right. Let's do this. All right. So, again, we are radicalizing this. We are breaking it down. We're making it look so radical. Getting it ready for its concert. We're going to do 5 first. We're ignoring everything else, just that 5. And that's going to end up being 5 to the power of 3/5. I write that radically as 5 power of 3. Denominator goes outside. Cool. All right, now we focus on that x to the 4th, okay? Just the x to the 4th. So, I'm going to do 4 times, can't cover it up right, 4 times 3. 4 times 3 is 12. So it's x to the power of 12. And that 5 goes on the outside. On the outside, on the outside. That's not how the words go. Now we deal with the y. Tell me why. I'll stop. All right. 7 times 3 now. 7 times 3 is going to give me 21. I don't know, 21. And the 5 goes on the outside. And unfortunately, this one cannot be reduced. Because 5 doesn't go into any of these.